Sometimes a solitary feature affects the region's climate, and other times an area's climate results from a multifaceted set of geographic factors. Just monitoring the regional climate is not a simple case of checking the weather reports, but it is about the overall climate which scarcely changes over time. Mainly, topography means the position of the land and is especially true in the mountainous areas of western United States still now. It can influence the climate and weather, and more certainly topography is the relief of an area which is close to the water bodies, as it tends to make the climates mild. Climate is what we expect and weather is what we get. Earth is included with numerous climate categories, and from them, tropical rainforest, tropical desert, wet coastland, marine land, wet subarctic and ice cap. Urban climates are a few examples of the types. And every climatic region has a separate set of geographical and environmental conditions affecting it. Topography is the configuration of land represented by contour lines, relief shading, and hypsometric tints. It is the study and depiction of the relative positions, distributions, and elevations of natural and man-made features of a particular countryside, such as rivers, mountains, valleys, railway lines, human settlements, and roads. It has its profound effect on the mountain barriers, creating deserts in their rain shadows like the rivers, which is valid. The study of topography and its effects makes the mankind know the effects of the normal landscape. It is clear from the weather forecaster that mountain barriers possess significant effects on the movement and development of anticyclones and its depression, and it is due to distribution of land and sea which also seems to transform the tracks of depression. To the point, topography affects rain and snowfall, which plays an important role in the precipitation outline. When air rises, it gets cooled, and the cooler air is capable of holding less water vapor than the warmer air. When the air cools, the water vapor is forced to condense, depositing snow or rain on the windward's slanting angle. The mountains like Sierra Nevada trap the moisture traveling off the Pacific Ocean on the western side, otherwise it might have passed without hindrance. And this action creates an effect known as rain shadow, in which the air has little moisture and the world's mid-latitude deserts are situated in rain shadows. In addition to it, the effects of topography involve creation of idiosyncratic regional winds, higher elevations and cool temperatures, orientation of topography and microclimates. Indeed, these types of effects have been observed and noted in many of the mountainous areas when one side of the hill or mountain is in a shadow and the other side is illuminated brightly. In this way, topography has many effects from nature and is explained in the following sections. Global climate system and mountains. The global climate is considered as the comprehensive and interacting set of components which has every part of land with chemistry. Here, the source of energy that drives the complete system is the solar radiation, which is most intense in latitudes where the sun is directly overhead as found in the tropics. As there is a surplus amount of solar energy effort at tropical latitudes, the task of the universal climate system is to change the excess heat from the tropics to the higher altitudes in which there is a radiated space. Actually, the agents of the climate system transport the winds in the atmosphere and the currents in the waters, means the ocean. Mountains are the high elevations which affect the climate by altering the positions of the wind, temperature, precipitation and circulation. To the most extreme effect is observed on temperature, which gets reduced with elevation. In it, the air temperature decreases, leading to a year-round snow and a high reflection of heat and radiation from the sun. Just think about the wind as a stream and the mountains in the form of rock in the middle of the stream. Here, the wind currents are deflected around the huge mountains and the current is changed to downstream. All this orientation process of the mountains affects precipitation and the winds get wetter and cooler, having moisture in them and also changing to snow or rain. The climate is affected mainly by land and water, and the oceans cover most of the Earth's surface and has vast amount of energy in the state of heat. It even has a large temperature which is resistance to change, and this is known as maritime influence, which means that the coming winds move air from the ocean side to the shore, where it restrains the winter and summer extremes. In point of atmospheric circulation systems, the storms are common to everyone as there is manifestation of energy transfer in the atmosphere, and these climatic systems are collectively or individually affect the activities and welfare of the humankind all over the globe for centuries. Due to the energetic force of these expressions of the climatic version, the energy input in the tropics has considerable effort which has been used up understanding the method and system of heating in the tropics. Certainly, heating of the land and the ocean surfaces are the starting point for the energy cycle. As you know, the surfaces of the ocean gets warmer than the overlying air from where the convection starts and the warm air rises. When it slows down, it cools and the moisture in it transfers squeeze from the clouds. For the easy way to understand, the topography is a barrier for mass of air as the warm mass of air gets coolest at the time of climbing the mountain from where the storms are formed. If the mountains are huge, then they are the great walls for mass of air from oceans, so that the zones are desert zones and semi-arid. Impacts on the climate, which changes over time. Every island, region and part of the earth has its own geology, climate, industries and topography with culture. In it, due to some effects of the climate, could bring comparable challenges to every island community which are found in both of the Pacific and Caribbean with higher level of sea and more energetic tropical storms and more warmer acidic coastal water like mangrove forests and coral reefs which are facing the stress from the mankind due to pollution, which is making it sensitive due to the climatic changes. Just have a look at the world map where you will view the world covering the land and water bodies. With this, you will see one more essential factor which has certain influence on the climate and the surface of the earth. Here, the amount of sunlight which is absorbed by the surface or reflected determines how much percentage of the atmospheric heating has occurred. The dark zones like vegetated regions are great absorbers, and the lighter areas like ice and snow covered regions are also the good reflectors. In fact, the ocean absorbs and leaves the heat in a slow way when compared to the land. In case of water, little by little releases the heat into the atmosphere, after which it distributes heat around the globe. It happens when the time the earth has formed that cold and warm periods interrupt the earth's history. In it, some are fairly short and the others are spanned from thousands of years. And in case of a few cold times, glaciers increased and spread over the large part of the regions. Subsequently, in the warm periods, the snow or ice is recoiled. Every period intensely affects the flora and fauna of the earth. Due to this, the global warming is in the list of activities of the man to save the earth. Indeed, every part of the earth comes across the effects of topography in every way, which lightly boosts the severity and frequency of the floods at the time of storms, grind down and overwhelmed coastline. Along with climate, the ecosystem also has an effect of topography. Islands are the home for most of the unique ecosystems and groups which provides monetary opportunities, nourishment, safety and cultural value to most of the island communities. It is all due to the changes observed in temperature, sea level, and the acidity of the water of the coastal lines, which could threaten the stability of these ecosystems. The inundations and loss of other coastal habitats, rise and storm bring hazard to the species which utilize these for nursing, nutrients, and nesting. In addition to it, the climate changes enhance the situations and conditions which facilitate the increase of persistent marine species and worldly pathogens, which has the chance to affect the island's natural ecosystems and biodiversity. Effects on economy, culture, and infrastructure. The far-reaching effects of the climate present a deep impact on the island infrastructure, local culture, and economic development. Their social events and leisure activities, island settlements, along with economic activities, have a propensity to be strenuous to the coast, making them helpless to the impacts of the climate changes from flooding, coastal inundation to the shoreline erosion. All these could affect the infrastructure and recovers faster and has the chance to become more resilient to these effects. And moreover, the long-time infrastructure damage could interrupt the services along with the tragedy risk management, education, healthcare, economic activity in certain sectors, and natural resource management. Even the topography effects shows intrusion on tourists' activities, warming temperatures, rise of sea level, beach erosion, ocean acidification, increasing storm intensities could threaten coastal activities like boating, coral reef exploration, along with fishing. It is more important to understand the base flow process, which is very complex, to the issues of water quality, habitat, and supply. This point combines the stiff portion of global literature, which interrogates the relationship between the watershed and base flow characteristics of soil, land use, geomorphology, along with the potential effects of the climatic changes, which presents an emphasis on the tropical, humid, and non-snowpack and dominated regions known as temperate. All these factors control the base flow with their strength on infiltration, subsurface storage properties, and rates of removal from the catchment. In addition to all this, the orientation of slopes related to the sun has a reflective effect on the climate. The south-facing slopes in the northern hemisphere is sunnier and ropes the entire separate ecological communities than the north-facing slopes. To the point, the south side of the mountain may practice the spring season weeks where the snow and glacier exist. They are raised by the shade provided by the west and north-facing slopes. Fortunately, this is the orientation of topography and microclimates. The regions which are coupled with high rainfall and temperature are the most favorable conditions of the effects of the topography on Earth. Topography effect on soil formation. Topography has its main influence on the soil due to up and down positions of the soil. The steepness of hill and mountain lets you know to what extent topography has affected the soil form. Due to this, all the soil over the land is getting deeper as low levels of dirt are being into the soil formed on the earth. Along with this, wind and water are the great carriers of the surface soil, which takes them in the form of erosion. The areas of soil which are flat get deeper in a quick way than the surfaces which erodes away. When observed about the steep slopes, the erosion takes place in a quick way than the formation of the new soil under it. The result for this is that the flat locations are more mature with soil layers than the one which have steep slopes. In these topographic effects on soil, the second factor is its effects on drainage to get rid of extra water by draining it. Actually, most of the locations have perfect and tremendous drainage, whereas in other locations, the water is blocked and this blocked water holds the oxygen which is necessary for the soil formation. In such cases, soil erosion can be easily and acutely stalled. Along with climate and water, the effects of topography are observed in soil too, as it has a strong influence on the development of soil. As the soil on the top of hills and mountains tend to be deep and light in color due to the leaching losses downwards. As you know, to some extent, soils are deeper in the valley regions with dark color and more horizons in them. This is observed due to the increase in deposition material from hillside corrosion, collection of greater quantities of water from the lower areas, and the material increase from downward discharge from the top of the hills. This is all due to the strong interaction between soil and topography, which influences the formation of soil and its erosion. Being a complex factor, the soil formation factors are dynamic continuously and interdependent as they help in the soil formation. Due to it, the effects are observed in nearby areas with less or high effects. Conclusion. Yet, it is understood that topography has a profound effect on the climate, which is equally valid along with the climate and soil. The mountain areas create high pressure on the leeward side, and the mountain valley experience unequal heating between the sides of the valley and its floor. In addition to it, valleys possess the capacity to intensify and funnel the winds that blow down. In case, if the nearby mountain is deep, then there is a change in the formation of cold winds, making the night and warm days. And the sea and land breezes affect the coastal areas. In a broader sense, topography is mainly concerned with every environmental feature which experiences topography in a general way. Anyway, topography represents the outline of the display of the land surface along with the relief and the place of its man-made and natural features. It has 5 moraines from north to south, and these moraines give relief of the land along with the division of the country into groundwater basins and watersheds. Besides the water bodies, topography of the land surface determines the general direction of the groundwater flow as it affects the recharge and discharge of the groundwater. Here, the recharge area is the place where the water goes to the downward side from high topographical area into the zone of diffusion. To the point, recharge areas refill the groundwater, and the discharge area is the area where the groundwater moves towards the surface to join into the lake, stream, spring or wetland. Even groundwater discharge happens from a pumping well. This is what are the topographic effects on the groundwater.